Okay, we're going to be looking at some problems on page 529 from chapter 10 about setting up appropriate null and alternate hypotheses. The first thing you need to know is that when we're dealing with a hypothesis, you're always testing a parameter. So you want to confirm that you were talking about a parameter. There is no need to hypothesize about a sample statistic, because if you wanted to know something about your sample statistic, you could put it in a spreadsheet or a calculator and find out what the value of that sample mean or sample standard deviation was. But for a parameter, we're trying to hypothesize what it is based on that statistic. So that's what the hypothesis is going to be about. Second thing you need to know is that for our purposes, a null hypothesis will always have an equal to. So anytime you see a null hypothesis, it should always have an equal to. And the third thing you need to know is that HA cannot, will not have an equal to. So if you have the null hypothesis, since it equals to be an alternate, it can't overlap, so it cannot have an equal to. So as we look at this, these examples here, we can very quickly see some issues. On the first one, our issue is that it has an alternate with an equal to. On the second one, the numerical values do not match. That is actually a fourth thing to consider, that the number values must match. It doesn't make any sense to compare 0.4 to greater than 0.6. So that is an issue there, that I have different number values. On the next one, that one actually seems to be good. It is dealing with a parameter. On D, that one is an issue because the number values do not match. And on the last one, you need to remember that your text, when it uses P, it's using it for a sample. So actually the way I would prefer to see those is written as P hat. And if you can see it as P hat, it is clearly that it is not hypothesizing about a statistic. It's hypothesizing, it's hypothesizing about a statistic, not a parameter. So that's the issue there. We're going to go ahead and look at number 4 as well. Number 4 is talking about which hypothesis is appropriate for the conclusion that's being given. And the conclusion that they had reached is that the researcher has said that the strongest thing he could say is that he doesn't see evidence that they are reducing crime. Now, one thing you have to realize is if you have statistically significant results, if you have strong evidence, if it is statistically significant, that means that you have been able to reject a null hypothesis. So if it's statistically significant, you have been able to reject a null hypothesis. So if he is basically saying the strongest thing he can find is that there is not evidence, it's a situation where he has failed to reject a null hypothesis. So the null hypothesis would not have been rejected. Now, to go back to part A, we're looking for one that says that he did not find evidence that they are reducing crime. So in this case, the alternate hypothesis you would be left with, if you would reject your null hypothesis, you would be left with the conclusion that they do reduce crime. So in other words, in this case, he has failed to reject his null hypothesis, which would lead that he did not have evidence that reduced crime. So this would be the pair you would be looking for, based on the fact that that he did not have strong evidence, he did not have statistically significant evidence, meant he was unable to prove his alternate hypothesis, and that is the alternate hypothesis he would have been trying to go to, that concealed weapon laws do reduce crime. Okay, the final one we're going to look at is number 10. It's talking about actually writing an appropriate hypothesis. In this case, it defines our parameter as mu, and it says that mu, in the problem it says mu is the true mean length of long distance calls. It's always important to define your parameter. In this case, they've done it for you, and I need now just to get a null and an alternate hypothesis. So my null hypothesis in this case would involve the parameter mu, and they're testing to see if the mean length of long distance calls has increased. So if they used to be 7.3, our null hypothesis would be that it is still what it's always been, it's still 7.3. Now your alternate hypothesis, since it's asking if it increased, you only thing that would prove your claim is if it was greater than 7.3. Now graphically, what you would be looking at there is you would have a sampling distribution of X bar that you would be assuming would be centered on 7.3. And we're looking for the values that are significantly greater than 7.3. So there's going to be some place over there where you're going to say, hey, that's enough bigger than 7.3 that I no longer think it's reasonable to believe that my distribution is really centered at 7.3. It must have actually increased. If it was just a not equal to there, instead of that, not equal to there as your null hypothesis would have meant I would be just looking for a change, whether the rate change caused the long distance time to increase or to decrease. But in this case, we just wanted to be concerned about if it increased the rate, so that's why we just did the one-sided alternate hypothesis.